We're going to use the superposition theorem to solve all the voltages in the resistors in this circuit. So we have E1 and E2, 15 volts and 12 volts, and 4 resistors. So as we discussed in our lecture, we need to solve for each power source by shorting out the other. So we're going to solve for E1 first, and we're going to short E2 as we did over here. Okay? So right away, we know that VR1, because it's in parallel with E1, so VR1 is going to be 15 volts. Okay? Oh, sorry. First thing we should do is mark our polarities. Positive, negative, positive, negative, positive, negative, positive, negative, positive, and negative. Okay, so VR1 is 15 volts. RT is going to be, we have R1 in parallel with all of this. And that is R2 plus R3 and R4 are in parallel when you short out E2. Okay, so that's what we have, which gives us 500 ohms in parallel with 470 ohms plus, bracket again, 200 in parallel with 1K. And that gives us an answer of 280.059 ohms. All right, so let's find IT. IT is going to be E over RT, or E1 over RT, which is 15 volts over 280.059, and that is 53.56 milliamps. All right, so we know IT over here. So going back to some series parallel stuff, let's find IR1. IR1 is equal to E1 over R1, which works out to 30 milliamps. So IR2, if we use Kirchhoff's current law, we have 53.56 milliamps here, 30 here. So IR2 is equal to IT minus IR1, which works out to 23.56 milliamps. Okay, so far so good. So VR2 is going to equal IR2 times R2, and that turns out to be 11.073 volts. And if we remember here, if we know VR2 and we know VR1, we can use Kirchhoff's current law here to calculate VR3, which is also the same as VR4. So VR3 is equal to VR4, which is VR1 minus VR2, which works out to 3.927 volts. So our voltage levels here, VR3 and VR4 are 3.927 volts. So we'll plug those in here. 3.927 volts, 3.927 volts. And VR2 is 11.073. And VR1 is 15 volts, okay, as we know. Okay, so let's solve for E2 now. So for E2, we short E1, okay? So RT, so when we short E1, we're also essentially shorting out R1, okay? So we'll just make a note of that here. Shorting E1 shorts out R1, all right? So RT, in this case, is equal to R4 plus R2 is now in parallel with R3 because this is shorted. R2 in parallel with R3, all right, which is R4 is 1K plus R2 is 470, parallel with R3, which is 200. And that gives us an answer of 1.140 kiloohms. Okay, so VR4 in this case, let's separate. VR4 is equal to R4 over RT times E, which works out to 10.526 volts. Okay, we did not mark our polarities. Bad boy, bad boy. Okay. So 10.526. So VR3, using Kirchhoff's law again, VR3, which is also equal to VR2 because they're in parallel, is equal to E2 minus VR4, which is 1.474 volts. Okay, so let's mark those in here. VR1 will be equal to 0 volts since it's shorted. All right, so VR1, 0 volts. VR2 and VR3 are 1.474 volts. 1.474 volts, and VR4 is 10.526 volts. Okay, so we have that there. So what do we do now? Now we need to take those values and put them back into our circuit. Okay, so VR1, if we take our two values here, okay, these are the same polarity, so we'll add them together, and VR1 is 15 plus 0 volts. Okay, so that is 0 volts, and our polarity remains like that. VR2, the two values are opposite polarities, okay? So we'll subtract them, and this is the greater, so this determines the polarity. So positive, negative, and VR2 will be equal to 11.073 minus 1.474, which equals 9.599. So right here, 9.599 volts. Okay, R3, if we take our two values, our polarities are the same, so we're going to add them together. VR3, so we have 3.927 volts plus 1.474 volts, and that equals 5.401 volts, 401 volts, so 5.401 volts. And again, they're the same polarity, so we'll keep that there. And then VR4, they are opposite polarities. This one is greater, so this will determine the polarity. And VR4, so we'll subtract them, is 10.526 minus 3.927, which works out to 6.599 volts. 6.599 volts. Okay, so that's what we have. Now, if we review what we were talking about in class the other day, okay, this should be 15 volts. Fix that. If we talk what we were doing in class the other day, 15, what we have is Kirchhoff's law works in this loop, okay? Kirchhoff's law works in this loop. So E1 minus VR1 is equal to 0, Kirchhoff's law. This loop here, these two polarities are aiding each other, and this is opposite. So this loop is VR1 minus VR2 minus VR3 is equal to 0, Kirchhoff's law again, okay? Let's take this loop, E2 minus VR4 minus VR3 is equal to 0. So the loops work everywhere. This loop here, we have E1 minus VR2 minus VR3 equal to 0. And if we take the big loop around the outside, okay, the big loop around the outside, we would have E1 minus VR2 plus, because now the polarities help each other, positive to negative, plus VR4 minus E2 equal to 0. So Kirchhoff's law works everywhere. Kirchhoff's law works everywhere. So, and if we want to see proof that this circuit does work, we have it right here, right there. Okay, so we have our values, 9.597. They're off by the third decimal place, 6.597, 5.403, and 15. So it does work. So remember, when you do solve these, you can use multisim to check your work. There's nothing wrong with doing that. In fact, you'd be silly not to use your tools that are available to you. Okay, so that is how we solve practice problem 1. So good luck with trying that on your own, and now you have the solution to refer to.